My wife Dana and I are similar in a lot of ways, but our minds work differently in at least one important respect. Dana is a planner. I tend to go with the flow and look for opportunities. We almost didn't have our first date because Dana expected that I would have planned out all the details a lot further in advance than I thought was necessary. But we did have dinner that night, and we hit it right off. Less than an hour into our 5-hour dinner date, Dana pulled out a funny-looking little device that looked like a pager with a small clear plastic tube coming out of one corner. I didn't see the tubing at first, so I just asked her, "Is that a pager?" No, it wasn't a pager. It was her insulin pump. She had purposefully planned to bring out her insulin pump and dose her mealtime insulin for that dinner, visibly in a way that would spark a conversation with me about type 1 diabetes. Despite my bachelor's degree in cell and molecular biology, I had no idea what it was like to actually live life with type 1 diabetes. And I knew nothing at all about the 20th century technology still being used to treat it. So, beginning that evening, I started learning everything I could about what it was actually like to live your life constantly watching your blood sugar. Our next few dates were even longer than the first one. So I had lots of opportunities to learn about monitoring and predicting blood sugar, about adjusting your insulin dosing, about trying not to let lows or highs, low blood sugar or high blood sugar, interfere with your life and your plans too much. I could tell that that part wasn't easy or fun, but Dana was actually really good at it. And so our dates were mostly not about diabetes, and they were quite a bit of fun. Working in technology, my goal has always been to automate myself out of a job as often as possible, so I can move on to doing more interesting work. That doesn't mean building an AI version of myself. It means identifying little repetitive things that I spend a lot of my time on and figuring out the simplest possible way to automate as much of that as I could. Very early on, we realized this approach would work really well for helping to support Dana with type 1 diabetes. She'd been living with the disease for over a decade and had learned how to live her life without too much disruption. But that was a full-time job, and she already had one of those. I couldn't hope to replicate her level of knowledge or intuition, but I did start to observe those common repetitive situations, and I asked her to explain to me what she did in those situations. She didn't always want to talk about it, but often enough, she shared what she was thinking. So to me, the obvious next step was to figure out a rule that could be applied in that situation. It helps, of course, that many of the basic rules for dealing with type 1 diabetes have been figured out a long time ago. People who are diagnosed with type 1 are sent home with insulin, which is both a life-saving medication and a potentially lethal one. They're expected to follow some simple rules and do the math to figure out what is the appropriate amount of insulin to dose at any given time, and what's the amount that can be done safely. We knew that those rules were not perfect, but that's the point we started from. Dana also had recently gotten a continuous glucose monitor, CGM, to allow her to see every 5 minutes an estimate of what her blood sugar was. That, of course, helped tremendously when trying to figure out which situations might need a slightly more nuanced rule to appropriately treat. So, with the help of her CGM, I started learning when that basic bolus calculator math needed adjusting for real-world situations. The first year of a relationship is always an exciting time, learning about somebody else in so many ways. But in our particular relationship, I was also getting to know Dana's diabetes, and we were both learning and starting to discover what more was possible. When we first met, it was impossible to get data off of a CGM without, of course, looking at it. But we soon discovered via Twitter that someone named John Kostick had figured out how to do that and was willing to share his code. At that point, our efforts to automate ourselves out of that particular job kicked into overdrive, because we didn't want to be hyper-vigilant monitors of blood sugar forever. So we built a louder alarm system to do the routine watching, to wake Dana up at night if needed, and to alert us only when something was actually needing to be done. Then we started making the system smarter, adding more rules of thumb. We gave it the ability to precisely calculate insulin dosing requirements and tell us exactly how much of that insulin was needed at any given time. And when Dana needed to do something else to keep her blood sugar within the safe range, such as, for example, eating some sugar to avoid a low blood sugar event that's coming up. We had it tell us that in advance. Pretty soon we realized that our steady progress was letting us do things that no one else was doing yet. Because we built that system together, we learned to trust it and to trust each other gradually over time. We didn't have to ask anyone's permission to do something new. We just built it, tried it out, and adjusted it until it worked the way we wanted it to. That sounds simple and obvious, but in the world of medical devices and drug dosing algorithms, it's a superpower. There are hundreds or perhaps thousands of professional researchers and engineers who've been working over a decade on this stuff. Specifically, they've been working to create, test, and get regulatory approval for a closed-loop artificial pancreas system. Now, that APS is simply a device that can use CGM data to safely dose insulin. But that closed loop is incredibly powerful. It lets the human living with the disease sleep safely at night. And it lets them go through their day without having to risk their long-term health. But those researchers are all slowed down by one very simple fact. They can't, or won't, experiment on themselves or anyone else without permission. So if they want to test an idea, they first have to write up a plan, a very well-defined plan for a clinical trial. Then they run it through an institutional review board, and they take it to the FDA or the appropriate regulator to get an investigational device exemption to allow them to do that test in humans. After all that is done, they're finally at the starting line of being able to actually test their idea. And of course, if they want to change the algorithm, test something slightly different, they have to go back and do very many of those steps, usually most of them, all over again. There are lots of good reasons for ethical restrictions on human subjects research, but the unfortunate side effect is it slows research way down. Dana and I are two completely unfunded individuals working in our living room in our spare time. We stand on the shoulders of other volunteers who have done things like Ben West, who figured out how to reverse engineer and remotely control a Medtronic insulin pump. But in those 3 years, we've developed the most advanced algorithms in the world for safely dosing mealtime insulin. Our algorithms are nothing special. The math is really simple. The code fits on Dana's shirt. But even so, they're more effective than anything that the well-funded university research labs and commercial medical device manufacturers have gotten into human use in over a decade of full-time R&D. Now, these algorithms are not just being used by 1 or 2 people. Shortly after closing the loop, Ben, Dana, and I released our code and our reference design onto the internet, completely free and open source, as the Open Artificial Pancreas System, OpenAPS. Shortly afterward, others like Nate Ratcliffe and Pete Schwam did the same. They developed their own systems and released them for free online. An entire community of do-it-yourselfers grew up around the hashtag #WeAreNotWaiting. There's now over 300 people who have built their own DIY artificial pancreas systems. And these individuals are using a lot of different systems, not just OpenAPS. There's Nate and Pete's Loop app for iOS. There's an OpenAPS-based system from Miloš Kozak called Android APS. And there's even a handful of people using other systems that they've built that haven't yet been released open source. But every single one of those 300 plus people is taking advantage of the freely shared work of others. They're implementing their own DIY solutions to problems in their own lives. And most of them are paying it forward in some way to help others. Our friends working at the medical device companies and research labs are doing their part to commercialize similar systems. That'll be huge, because they can make them available to 300,000 people, not just 300. But those traditionally responsible for innovation could be moving faster. We should all start abandoning some of the constraints that slow us down. We should be collaborating with and learning from those we seek to serve. Now, most of you probably are not biomedical researchers, but are you a professional or aspiring to become one? If you are, is your profession constrained from doing more good in the world by rules and procedures? Or are you constrained by doing the things the way that they've always been done? How could you bypass those constraints and make more of a difference in people's lives? What about the parts of your life where you're not a professional? Are you taking the initiative to solve real problems in your own life? Are you sharing your solutions as widely as possible? Why not? Do you really want to make a difference in the world? Do you already have a plan and know exactly how you're going to do it? Most of us don't. But if you're looking for them, opportunities are everywhere. Look for small problems that need to be solved. Try things out. Share your solutions. Build up incrementally toward bigger problems. Obstacles will block your path, and some of them will be too big to climb over. Figure out a way around them. We got this far because we are not waiting. What are you waiting for? Thank you.